Hi, Mark here with My Engineering. Today we're going to do a video walkthrough on how to get a two-dimensional cross-section, like a DXF file, from a three-dimensional surface. So what I mean by that, if you can picture on this dish soap bottle, they have a product label that was cut out of a piece of paper, uh, two-dimensional, but it's wrapped around a bottle that has curvature this way, has curvature that way. So if you were to take just that shape and you need it to fit in an exact space, it can be very difficult once you actually start wrapping it because the geometry changes a little bit. For the examples today, we're going to be using a jet boat and we're going to be using a car door. So two surfaces that always have a lot of curvature. There's in most objects, there's strength in curvature. So you think like a car door, unless you're a Cybertruck, it always has a little bit of a uh, maybe some curvature this way and that way. So if you were to say want to make a decal or a magnet for your car door that you wanted to say make it rectangular, but you didn't want to, once you wrapped it on, have some weird deformities where it's not straight lines anymore. Maybe it's kind of stretched here. Maybe you have a little bit extra. Um, Same thing on a boat. So let's say in this example, we want to place a nice piece of foam on this curved surface. Uh, you would have to make essentially a template out of cardboard or something like that, lay it on the flat, and then use that as your cut file. We can do it quite easily and quite accurately in 3D space. And so we're going to use QuickSurface today, and I'm going to walk you through how quickly and easily we can get there. All right, so we're looking at the back of the jet boat here in Artex Studio 19. And if we were to look a little closer here at the swim deck and pull a cross section, um, if we wanted to make a nice little piece of foam for this deck, we picked 3 points to make our plane. Then we just want to move that plane up just a hair. So what you actually end up getting is the boundary wall. So that is how you'd get a general cross section for a piece. You could make that, but as you may notice, there is no line separating the back of the jet boat where the swim deck drops off into the water. And the reason is obviously the plane is now above the deck, so you're able to get the back walls, but you can't get the bottom unless you were to drop the plane down into the deck slightly below. Now you get the back of the boat, but you don't get the surface where it goes up into the engine compartment. So a typical cross section, you don't get the entire picture necessarily. Now, on the more extreme end of where we want to get a two-dimensional cross-section file, we're going to look at this little piece on the front of the bow of this boat. So it is curved. Um, you can see here it's got a lot of curvature going towards the very front of the boat from the side. It is angled. So if we were to use that same method to try and get a cross-section, so we want to pick 3 points on here to make it plane, it is nowhere near what we need. It is so we're very challenging. You can try and move the plane up and down. You're not going to get the data that you need. So that's where we're going to jump into QuickSurface, and I'm going to show you guys how to get that data very accurately and also very quickly. So I've brought our boat scan now into QuickSurface, and what we're going to want to use here is the 3D sketching tool. So what that's doing is it's going to allow us to draw polylines along our mesh surface. And if we want to say on the back of the boat here, it's a nice curved surface. You want a nice gentle curve. All you have to do is keep placing points along the curved edge, and it will make a nice gentle line that will follow it. And there's a lot of trimming tools. I'm not going to get into that for the purpose of this demonstration. But yeah, now we have a nice polyline, so we could say OK. We'll select this. We want to fill the surface. OK. Now with this filled surface, what we want to do to make it a two-dimensional, because even though this is a flat surface it was generated on, it is still technically a 3D surface. We want to use flatten. And so what this function does is it turns your 3D surface, filled surface, into a flattened 2D DXF file. And now this DXF file is what we can export into whatever CNC machine or whatever. This is our two-dimensional file for a three-dimensional surface. So let's apply that same workflow to this skinny little surface that goes from the side of the boat up to the bow. So we're going to use our 3D sketching tool again. And essentially, We just trace along the edge. And the line will keep attaching itself to the mesh to keep it nice and tight. And now we have a nice polyline outlining it in the 3D space. You can see it follows the curvature of the boat. It's attached to the surface of the mesh itself, but it is a 3D component. So what we have to do is make it a 2D surface. We'll select it, click on Fill Surface, OK. And now with this surface, we're going to want to flatten it. And you can see it now in 3D space. It's just kind of floating out there. That is a 2D surface. So if we look at this little surface, it actually is flat. So just to review really quickly, you have this curved surface in 3D space from the front of the boat. It has a 2D file right here. And then you have the swim deck from the back of the boat. And again, you have a 2D file right here. So for our next piece now, I know I said initially a car door, but what I'm actually going to use is a car fender. I was just looking at the geometry changes on here, and it is a lot more pronounced. So it's better to show probably a more extreme example of the power of the software than just the slight curvature you'll get in a car door. So again, we're going to select our 3D sketching tool. Okay, now with our part sketched here, we just have to go again, fill surface. Okay, we're going to select that surface and flatten it. So if we turn off our mesh, we can see here in the light green with the yellow highlight, that is our 3D surface that we created. And then above it, you'll see our nice two-dimensional flat surface that we could send to our cutting machine if we're going to cut a decal or anything like that. So as you just watched, it only takes a few minutes to create very accurate two-dimensional files from three-dimensional parts. Whether you're going to be creating a foam cut file for the back of your boat, or a new decal, perhaps some kind of a protector for a fender on a vehicle, or even just simply a new product label on a bottle of dish soap. The user interface on QuickSurface is easy to follow, very easy to learn, but the tools themselves are actually very powerful. As always, we'd love to hear your guys' feedback, or if there's anything else that you would like to see that we haven't yet covered, leave a comment below, or you can email us at support@myeng.ca. Thanks for watching, and we'll see you in the next video.